I don't know, everything is happening because of social media these days. And this talk is happening because of the social media questions. There was a question at the time when I was working in the real-time analytics company. We were building real-time analytics database. And one of the community members asked in Twitter, like, what would be a canonical way is to use something like a real-time database to query Kafka, or using something like Kafka streams to do this. And my boss came in saying, yeah, that would be a nice talk. And this is the talk that talks and explores this subject of the things. Anyone fans of the Studio Ghibli and Miyazaki movies and cartoons? And anyone's played around with ChatGPT recently? How to generate this? Like, we're all guilty of this. So I built whole talk only using the pictures that were generated in style of Studio Ghibli. So this is, I'm giving you, one does not simply query a stream. We have a stream that would be our Kafka. And after that, we're going to go through the journey. I will show you some of the opinionated solutions. Some of them is already general knowledge across the data community. So there's nothing controversial here, I hope, I suppose. Any Scala developers here? All right. We every year less and less. I used to have a joke about the Scala developers, for Scala developers. I forgot this. It will come back to me. But yeah, nothing to do with the talk. Like, I just see how many Scala developers in the room. That's it. This is what Get Me doing. We have a stream of data that is inside the Kafka. It's a general agreement that your data is in Kafka. Anyone disagrees with this? Okay, your operational data ideally should be in Kafka, because everything should be, by 2025, should be real-time-ish and streaming-ish. No? We're still using, anyone, Postgres for their operational data? Something else in operation? What you folks using? DynamoDB. That's a good solution. In the world where I live, and again, I'm a very, what's the word I'm looking for? I'm biased because I live and breathe of the stream. And in the world where I live, like, all operational data is in Kafka streams. Like, if it happens in the form of event. And after that, we're going to turn into something that would be related to the business. Maybe it would be entity. There would be some sort of history log that describes what happened with the particular entity. But everything happens in the stream. And we try to fetch something from the stream. I will show you few different approaches. At the end, I'll give you a couple of advices what you should pick in your real life, in your projects. My name is Viktor Gamov. I work as a principal developer at a company called Confluent, original creators of Apache Kafka. As a developer advocate, I love to travel and talk to people about stuff. I'm building demos. I'm building talks. I spent some time in a data world, in professional services when I was at Confluent. I wrote a book about Kafka. So I know a few things. So you can follow me on Twitter or X or Blue Sky or LinkedIn if it's much easier. And my Twitter would be conveniently placed on every slide. So when we mentioned like operational databases, when we have one place, one application writes in one database, everything is analytical, everything is easy, everything is manageable, until it's not, right? So until it's either size or latency or concurrency problems that we're facing to just try to get this data out of this monolithic application. And the way how people would breaking down this monolithic application is by, slicing this, dicing. Maybe outsource or like offload some of the data from this monolithic application to another system. Say we have operational data where we're counting transactions, we're counting swipes of credit cards. Whereas in other places, they would be care not about individual transaction, like in the fraud detection, we care about individual transaction, but in a system that would be, say, doing some sort of report of your transaction, like what you're spending your money, groceries, electronics, entertainment, you don't really care. So you're trying to move this out of the system where you're operational because you don't want to create additional, problems to your operational data. So that's why using techniques called ETL, we extract the data from our source of truth and move this into some another source where we're going to be doing something with this data. So ETL and CDC is the way how we can capture some of the changes that happens on our operational database and turn them into stream of those changes. Now, and it worked very well. Worked very well for some time. For the last, I don't know, 7 years, we have a rise of event-driven microservices where we push this data into Kafka through the format of the change data capture, and some other microservices will react. Some data pipelines that Roman, for example, showed, like different architecture emerged from this. You have a like speed layer, you have a batch layer, and there's like unified architecture. There's Kappa, there's Lambda, there's bunch of different patterns already there. It's good, it's nice. In all thanks to one magical, not the magical, but technically it's like very clever and more or less not super complex piece of software called Kafka. Kafka represents a collection of logs that's streamed, right? I think it's captured like perfectly. And now everything goes like somewhere. It's append-only. You cannot just like when you publish the event there, it's gone. It's kind of like the event is something that's, for example, you have a conversation with your significant other and you make a comment that you should not. You cannot change that. It's already happened. So what you can do, you can send another event to try to amend changes that you say, I'm sorry, I was wrong, this type of stuff, It's not difficult, boys. So that same stuff happens with Kafka. If something needs to be changed, it needs to be changed, sent in the form of another event. Now, it gives fantastic data structure for storing the data because it's append-only. There's no need to random change and all this type of jazz. But this creates very complex ways how we can actually consume this data and what we can do with this data. Now, for this particular talk, I want to kind of distinguish two, I already mentioned this a little bit. I want to distinguish our OLTP streams of transactions, streams that come in from the operational data set, and OLAP streams, where with OLTP, you care about the individual message. With OLAP, you care about the story, what kind of story this data tells. We have a credit card transactions. Individual record will say that this particular transaction contains certain stored, and it is for a certain amount, and it's approved or not. With the OLAP stream, we care about how many transactions for the last hours came and become fraudulent. So we care about the story about the massive number of this transaction. And those streams, those stream of data can produce these stories. So we need to find the ways how we're going to be looking at this one. So I will be pointing out during the talk different solutions, how they will serve the OLTP case or OLAP case. Okay, make sense? Anyone? All right. So a couple things that we're going to be talking today. We're going to talk about Kafka Connect, how it helps to query stream. Kafka Streams as because it's kind of like an in-store brand, you need to know about those things, and you probably want to use those things for certain use cases. So Kafka Streams and Connect is a part of Apache Kafka offering. Well, next we talk about special kind of databases that start emerging in the last 5 years, at least 5-6 years, is streaming databases, streaming SQL. Just because I spent a little bit of time in the world of real-time analytics, I want to talk about those as well, because I think it's a almost perfect solution for doing the things what we need to do with the stream. And we're going to talk a little bit about the data warehouse. And at the end, I really want to show you something that is really cool. I think it's cool. I don't know. You might be disagreeing, but I still will show you. So let's start with two technologies that, like I like to call it, it's in-store brand. It's something that comes with the framework. Using Kafka, and there is a very cool framework for data integration. So instead of writing your application to bring data in and out of Kafka, how many applications you need to write for Oracle if you need to get the data from Oracle and push into Kafka? 5, 6. Why you need to write 5 or 6 where you can just simply use a connector? So connector, it's just a library usually provided by vendor of this either source system or sync system. So in this case, data can land into Kafka or data can be extracted from the Kafka. And for the simple use case, how you want to query data from Kafka is essentially you are taking this connector to your whatever database, and you write the queries whatever you're comfortable with. So that's it. So the job is done. I like to say this is suitable for smaller data in sense of it's not like megabytes. It's maybe still a couple terabytes, maybe gigabytes. Probably you don't want to deal with terabytes because you will start getting some other things. You need to figure out indexing story and the storage story and all this kind of thing. So probably would be not suitable for like the big data. Usually oriented around transactional streams because the way how Connect works, it actually takes the data per message and doing something per message. So you don't do any type of aggregation on Connect side of things. You take a message will be transformed in the format that your underlying system will support, and it ship it to the system. Say you have a database and you have a schema in schema registry. So these schemas would be somehow mapped. If you have a flexibility to modify schema on your underlying system, it will be modified by connector, and so far and so on. Now, and again, it's the many users already know how to use this stuff. People like it, and they will continue to use. Simple illustration. External service, you need to run this. It's a part of Kafka as a framework, but you need to run this and maintain as a separate entity. So essentially, that's your kind of like a poor person streaming ETL. You have a data streamed through the connector. It lands in some external system. There was tons of different connectors. You can go to confluent.io/hub. You can find all possible connectors to your database. Virtually, like, let's try it. If I do, just name your database, and I'll see if there's a connector for it. Which one?
ClickHouse.
ClickHouse, easy. But for ClickHouse, I do have a special type because ClickHouse. So this is the sync connector, meaning that we ship data from Kafka into ClickHouse, but ClickHouse itself has a capabilities to get data from Kafka natively, and it would be much faster. All right, we're getting back to this one. You can play around to this website. You can find the connector to your database. It's there. It's cool. Here's the problem, though. Like, you might not have, you still kind of like streaming data. You're dealing with the batch world. There might be some delays. You need to maintain these databases, but still, you have this bucket where you can have data. Now, next one, this contraption, I give you Kafka Streams, my personal favorite, because I came from the Java world. I feel super comfortable writing Java applications, enjoying my jars. What's your favorite build tool? Any Java developers or JVM developers? And what's your favorite build tool and why it is Gradle? Okay, no? I learned last week there's a new Scala is trying to come back, like from where we didn't expect it. Like, we know like SBT sucks, but some people decide to reinvent the build tool that would be fast and still using Scala as a build script. It's called Mill, M-I-L-L. I was surprised that it's actually kind of like doesn't suck. So anyway, Kafka Streams. It has the two kind of like options where you can deal with this, with the data. One is transactional. So Kafka Streams has very intimate connection to Kafka, hence the name, right? Kafka Streams, Kafka. Essentially, the architecture of this Java framework is very much connected to how the data represented inside the Kafka. Even though it's a Java framework, with Java framework, they're trying to kind of like stay in the world Java util stream style API, right? And like how you're dealing with collection these days. But still provide you the underlying kind of things that related to Kafka. So there's an abstraction called key table that you can query by key if you know the key. So that's why it is like a inherently transactional system. This key table is in memory, even though it has capabilities to have a persistence in the Kafka side of things. And that's kind of like plus and minus, pros and cons. As I mentioned, like this intimate connection with Kafka will infer some of the limitations, how you can scale. For example, if you have 10 partitions, your Kafka stream applications cannot scale more than 10, because otherwise it would be idling, because this is the way how the consumer group works in Kafka, and so forth and so on. Anyone using Kafka streams these days? All right, few people. Don't be shy or shamed. It's cool technology. For the rest of the people, since they don't use this, I'll show you code. And I'll show you how it looks like. So and I don't know, like I'm enjoying this because it looks like a Java util stream. I'm getting collection of things, and I can apply different functions. I can do a flat map, just take a stream and explode the stream into another new stream. I can perform things like a group by, and this is where I actually accessing to this thing. So it's an example where I am using the word count. Hello world of data, hello world of data world, right? So you need to learning your tool, you're running hello world instead of hello world, you're running word count. And with this, I have a Kafka topic called input topic. In this case, I have a key as a string and value as a string. And as you can see, this is how the model of the data maps into the types that will be used in the framework. And after that, I can do things like create a materialized view, so I can query results even after I process. So I don't need to go and reprocess every time I need to get to count. I can have this intermediate store where I can query this. So this is why you need to know the key. So that's why it is a transactional, like inherently transactional use case. With Kafka streams, you can also implement analytical use case. So you can perform all sorts of aggregation, find like more interesting story, aggregate things into this. Again, you need to be very comfortable with Java, key table is also kind of gives the result how we can query this the state back. In this particular use case, what I have, I do use this approach with external frameworks because Kafka streams doesn't give you external interface. It's Java or nothing. So in this case, I need to use something, say, hey, there's my web framework like a REST API, and I wrap my word count store into this REST interface. So everyone will be going and query my application. So cumbersome, very limited to certain things. Every time you need to write new query, every time you need to write new use case, new query, you need to write new application, new topology, new Kafka streams application. You need to deploy it. You need to maintain this. I love this. Not many people do because people want to solve the problems. It's kind of sort of like a querying the stream, but it is not. And this is how it would look like if we're getting back to our picture again. If we know the key of the message, in many cases we don't, it has a limited scope of the things. Only if there would be something that allows us to use this beautiful technology and using SQL, right? Stay tuned for a few more slides because there would be interesting technology that took this idea somewhere. Now, like I said, for the last 5-6 years, when I was doing in this data world, I've seen emergence of this new type of database. And it is database. I will give you clear definition why I feel it is database. It's called streaming SQLs or streaming databases. And 3 key indicators I give you, in my opinion, and the opinion of a few other people, how you can distinguish this new type of product. So first of all, you're using SQL for queries. As a Java developer, I am extremely disappointed. I never wanted to learn SQL. When I started, I was like, oh, I have a Hibernate. I would just like, the Hibernate will do the thing for me. It will turn everything in SQL. I don't need to worry about this. Turns out, not so much. SQL here to stay since 1992. It is generally acceptable with some modification, but in general, people understand how they deal with the data in SQL. Second thing, streaming source, it could be Kafka, it could be Pulsar, it could be Red Panda, it could be WarpStream, it could be anything, is the first class citizen, meaning that there would be either connection to like directly to consume the data, so you don't need to worry about this yourself or like shipping this data there. And third one, this is important, the persistence of the storage. So your say you created this materialized view on top of Kafka based on certain SQL, you should be able to query this after that without recomputing. So that's three things that you can see in the next couple use cases. So KSQL DB, materialize, rising wave, time plus. Anyone heard anything from this list? All right, few people heard about. Anyone heard about KSQL DB? Materialized? Less. Oh, okay, still it's interesting. Rising wave. Okay, few people. Rising wave and time plus. This is particularly beast because it has a lot of properties of the things that I'm talking here. It's the we'll talk later about this. Now, let's talk about this elephant. Oh, not the elephant. It still gives me Hadoop vibes, but like let's talk about Flink. Anyone Flink people here? Some people can ask, but Vector, Flink has SQL. You have different tables in Flink. Is it streaming database? And the answer is no. Flink is not streaming database because Flink is the stream processing framework that uses SQL as kind of like a DSL to define the jobs, to do kind of like a computation. But at the end of the day, you can do certain things. You can use Flink as your foundation for building your streaming database, but without having kind of like a storage story, like how you will query results, intermediate results, is also not super clear. The good thing is that I don't have answer for this because its answer will take another 30 minutes. But my good friend David Anderson has it for you. If you go to this YouTube channel called Confluent Developer, you can find this video where he explains all things about why Flink or Flink SQL is not a database. And you can use this in, I don't know, in the next flame war or conversation you have at work or somewhere on the internet saying, yeah, Flink is database. No, it's not. Watch the David's video. Flink is not. So we're not going to talk about Flink. We're going to talk about some other things. So now, KSQL DB. There was an idea to have a group of remarkable, different idea. To have a beautiful idea of Kafka streams. I showed you, like API is great. You see all these things and nicely implemented. But what if we will take this as a foundation of the framework or foundation of database, adding some of the bits with the storage, adding materialized views, and maybe turn it into, the streaming database. So streaming database, you see this air quotes, and remember I was talking about the streaming database. I said like SQL. What was the second one? Streaming source support. And what was the third one? Storage and persistence. It has it, but in a weird form. So it's KSQL DB provides SQL, which a little bit it uses its own flavor. Let's put it this way. Second thing, it has a connection to Kafka. It has an intimate connection to Kafka because it's based on the Kafka streams. And the third thing with the storage. And the storage story, it's also used Kafka as a storage. Not only it uses Kafka as a source of data, but also it uses Kafka as your like intermediate state, replication state, and all these kind of things. It has a persistent table abstraction. So when you created this table constantly populated, you will be able to have a few interesting type of queries. You can do standard pull query. You can write select star, you get the result, or you can do select star, emit changes. So in this case, your result will be constantly updated from the data that comes from the Kafka. So data from the Kafka comes into KSQL, it will be processed and sent back to user query. The way how it looks like, and the SQL would look something like this. KSQL DB, boom, boom, boom. Where's my readme? Yeah. So if I want to deal with the, where's the, oops, too many. Let's do it bigger. Okay, so this is the way how you will be connecting things to Kafka. In this case, you have a special word create stream from Kafka, from input topic, and you specifying the value format. And after that, you will be able to, in this particular case, I'm getting data from my input stream, creating table as select. And here I'm using some of the variation of this, like a flat map and grouping that was available in my Kafka Streams applications. In this case, this is kind of like unnest will create another stream that will contains only words. And the way how it will be landing as a result, back to output stream topic with this init changes, meaning that every time there will be new word arrived into Kafka topic, it will constantly update this materials view. So that's the KSQL DB, the interpretation of streaming SQL. Going next, materialize. So it's an interesting thing. It's not Java. It's implemented in Rust, as far as if I remember, based on certain things that were Microsoft Research was doing with the special model of computation of the data. Integrates with Kafka, integrates with your not only with streaming sources but also with batch sources. And you have this materialized view abstraction that would be constantly populating with data. Another cool thing that you also might notice across these streaming databases is that they might have compatibility with your existing tooling. So that's why they're providing this Postgres wire protocol. What does it mean? It means that your tools that know how to connect to Postgres will be able to connect to materialized. It doesn't mean, though, you can run your Postgres queries there. Probably in 75% of use cases, you will be able to, because they also have the SQL that is compatible with Postgres. But in general, it means only that tools can connect, but queries still need to be materialized. And the way how it looks like, let's see if I have the if I have a materialized example. I don't remember if I have it. No, we're going to switch to another one, to Rising Wave. So Rising Wave, it's interesting system. It's also not JVM. It's written again in Rust, I guess. It's a stream database available in open source and cloud. Blah blah blah. I probably will get in a fight one day if I would say someone and someone will disagree. But it still feels like implementation of Flink on Rust. But people say, no, it's not. It's kind of different, but it's still kind of the same. Yeah, it's still ideas that Flink has implemented there. And Kafka, Pulsar, Kinesis are integrated with the basic language, with basic SQL, so you will be able to connect to the sources. And it has a concept of persistent view. And this is how a world would look like if Flink was not written in Java and JVM. So this is how this would be working. Again, it also has a wire compatible protocol for Postgres. So you can connect your, and even not you even connecting, they are recommending to do this. If you looking into in their SQL, I'm sorry, this one, yep. The way how it looks like, same use case. So instead of creating stream, how we have in KSQL, we do have a create source. Very similar to what the Flink does. In Flink, we have a table that specifies connector, and this connector brings us into, bring data into this input table. So in this particular case, we're using this source. Very similar how Flink does things. You have a connector that writes data back to Kafka, Bootstrap server, output topic format. And this is what we're getting as a result. We created this materialized view, so you don't actually have to write output because this materialized view is fully queryable. Just connect to the to Postgres. They even have this. Where's my command line? I think I should have it somewhere. No. So if I would connect this to Rising Wave, this is my Kafka Rising Wave. And I will be using this like PostgreSQL client to connect the Horizon Wave to query this database. So, by the way, this code is also in that website. You can play around with this. Again, SQL connection with Kafka, persistent views were compatible with Postgres. Materialized view on top of stream of data. I think it's pretty fine. Now, for the real-time analytics, anyone heard about real-time analytics? At least you should probably heard about since you asked about ClickHouse, and you probably know a little bit about real-time analytics. This is where, like, new world of dealing with the data. From one point, you have analytics, like Victor, but analytics, usually it's kind of like not super real-time. It's okay with data from yesterday or from last month or from whatever. But how this would get us to, like, what's up with this real-time aspect? And essentially, the idea of real-time analytics came from building this system that would be both support high concurrency, so the users can query this data, and multiple users will be able to configure, like hundreds and thousands users, with very low latency. And streaming sources should be just a must. So we need to get the data in, since the streaming sources is kind of like a real-time implementation. And it has integration with Kafka. And from users, it should be something like a conventional, like writing SQL queries. So I spent a little bit of time with Apache Pinot. Apache Pinot is super cool. Anyone heard about Apache Pinot? Okay, a few people. So it is cool that anyone heard about ClickHouse, Apache Druid, Apache Doris. Oh, interesting. I probably StarRocks user. You probably StarRocks user? No? Oh, interesting, because StarRocks is kind of like a fork of Apache Doris. And actually, not many people heard about Apache Doris before. Or there's Apache Kylix. Is anyone? It's another real-time like analytics database. So they shaped for analytical use cases. And one of the use cases I used to tell people, because I was at the Pinot world, and Apache Pinot actually powers every time when you go to LinkedIn and watch anyone go into LinkedIn and watching who viewed your profile. There's no shame in this. You know, nobody's Googling yourself. All right, few people. So essentially, let's assume you don't know what it is. Who viewed your profile? It's the real-time data on who viewed your profile. So I would do this every time I'm doing Meetup. I tell people, go find my LinkedIn, and after that, I go into this dashboard and shows me who viewed my profile. And it's a real-time, because data that happens in the LinkedIn is captured. Everything that happens in LinkedIn captured in the Kafka. You click around, you click the pages, and this will generate event that will land in Kafka. Now, on the other side, there's a widget saying that who viewed my profile, and it is inherently analytical query. It has multiple dimensions because it might have places where the people working, what's their job titles, what's their, when they saw my profile, what the company, department, or whatever. So you will be able to capture this information and display this information almost in real time with very low, the freshness would be in minutes. Friend of mine used this approach when, just to feel good about himself. Every time when he went to interview, we interviewed some company. After that, he went and watched who viewed his profile, and he felt good about his performance on the interview if he saw someone from the same company viewed his profile, I don't know, minutes, hours after the interview. It's pretty cool, but it increases engagement in LinkedIn. People start using this thing, and that's why these analytical use cases become very popular. Another example I showed is the fitness tracker called Whoop. I don't know if anyone used the Whoop, W-H-O-O-P. Very popular in States. Essentially, it has like a sensor that collects your heart rate. And that's it. It syncs with application. You're not entering any data. But when you wake up in the morning, it gives you a report how you slept. That's based on the data. Again, remember, Analytical, it's all about telling the story. Transactional, it's about individual record. We don't care about one individual heartbeat. We care about the story, how well we slept. And this is the systems that allow you build this type of use cases. Oh, cloud data warehouses. Any Google BigQuery users? Few. Okay. Redshift. Few people Redshift. Snowflake. Right? Few people Snowflake. Synapse. So I'm not an expert in the cloud data warehouses, but I can see that like they all using for some reason blue logo. Probably there is somewhere in some department where like 8 or 10 people discussing about the color or like the shape of the gradient that needs to be used. Anyway, so cloud data warehouses. You take your big data warehouse, bring it to the cloud. Essentially, nothing changed except now you don't need to worry. They will worry about the costs of the storage. You will be not responsible for this. You will pay for them. And they also historically batch-oriented. Loading files, loading data through traditional ETLs. You have a batch job that extracts the data from your system and push the data into our data warehouse. Some of them support streaming sources. You can also write down things from Kafka events and stuff like that. But structure needs to be established. So cloud data warehouses is the, there's nothing interesting there. It's Kafka there is just one of the sources. Now, as you can see here, I have a lake and I have a data. So it's a data lake. Now let's talk about data lake. What's the data lake and how we end up here? Essentially, data lake was the one place where you can put unstructured data, and whenever we need this data, sometime we'll figure out how to deal with this. So it's mostly kind of like, okay, let's bring this everything in, and I think it's kind of like an ETL versus ELT. So we extract this data, we'll load this somewhere, and we will figure out about the structure. When we will reading this data back, we will figure out what kind of schema would be there and stuff like that. Now, interesting aspect of architecture of the data lake, since it also supports the streaming sources, the compute part that runs your query and your storage part, it's also very important for our conversation in the next couple of slides that you, and also very important for the conversation that Roman did. Storage and compute, they are decoupled. Your data, usually somewhere in object storage, is going to be either GFS or S3. And structure, not so much is important, at least in the very beginning of this data lake world. Since the storage and compute decoupled, your reads would be slow, and it was designed to be used in a batch fashion. Few more words about data lakes. Like started as the GFS cluster, become S3. S3 right now is everywhere. That's the standard storage that we're using. Didn't help. Like I said, the ELT versus ETL. So we need to extract load and after that transform versus how we do transformation upfront. So we don't think about transformation upfront. We're thinking that, okay, someday we will need this data. But there's actually something came out from this like a data lake world that actually very popular these days. I don't know, like there should be Zulander clip here. Like Iceberg is so hot right now, like a Hansel. Anyone? Zulander? Anyone? No. Okay, so after this presentation, so two things. You come back home with your significant other. They will ask you, okay, so like where you've been? Like your work should be over a couple hours ago, and I appreciate that you came here. That's very important. And so, you know what? I now learn all possible ways how to query Kafka stream, but also we have to watch Zulander today. And you will be watching Zulander. So the Iceberg is pretty hot today. No pun intended. So remember I was talking about the structure of this information. Initial formats, they will not care much about this because it was responsibility of the party that will be reading the data, will be taking care of the structure. Iceberg brought some of the cool things into the table. Again, no pun intended. So one of the things that someone implied during the Roman's presentation, but it was not directly answered, is that with this dimension with time, we can do time travel queries. So some of the records will have some additional, I think you were asking about offsets and how it will be translated into like a timestamps and stuff like that. So this information also can be used to perform some sort of like a time travel queries. Say you have a data in Kafka topic that comes on the same key. So in this case of Iceberg, when it would be materialized in Iceberg, when you will be query, it will get the latest and greatest based on the way how, based on the policy, how this data, usually it would be latest and greatest value. But you also will be able to return in time. When you say the query from time, you will be able to execute this query also on top of the certain time frame. And the table format allows to kind of define the structure. Now, that's Iceberg. And now we talk about this today about transactional versus analytical state, and ETL didn't help that much. And some of the things that Roman mentioned with the projections. So I think that everyone, like all data vendors, they actually doing something interesting with this, and they actually getting closer to somewhere. So the table flow, that's our kind of like answer to this question, how we're gonna bring this together. So at Confluent, we're known as a Kafka company. We have a managed service, we have like something that you can install yourself, we support open source, and we live here. Like majority of the time, we live in the operational world. We live in the stream. Now, we realize that many customers who use Kafka, they not only live in this world, they also need to be getting like stories, they need to get reports, they need to get this analytical thing into play. And the things what you saw on the previous talk, like we need to use external tools, say like to bring the like ETL jobs. We take this data through all the tools I showed you today, connectors, streaming databases, the stream processors, Flink. There's always something in between that you need to bring from your operational store to your analytical. So table flow, in a table flow, we use these abstractions on giving you access to your Kafka topic in the form of Iceberg tables. So in this case, it's actually something to do with the storage. We control the storage for our Kafka, and we can turn this storage and represent this in the way how the people would see this as an Iceberg table. So the way how, and again, it looks something like we saw in the previous presentation, but Confluent Cloud. Where's my password? Just a moment. And let's see if I'm still pumping some data. Let's run some data generator. So I do have a topic with the flight information here. Son of a. That's why I don't like Google Meet. I can close it. It will not cancel the meeting. So the data comes in here, and in other world, you see it's streams. What I need to do is set up ETL pipeline, and this ETL can be the standard tools or tools like a Flink. We do have like Flink that runs inside Confluent Cloud, and it can do that data massaging and all these kind of things. Now, but I want to get this like flight information in my dashboard like immediately. And so what I can do here inside my Kafka topics, we do have this table flow thing. And that shows me how fast it synchronizes it. and that writes it into this storage. Someone asked about the storage on the previous question. I don't remember who was asking. We support both. We support give you managed storage, so we manage storage, or you can bring your own cloud provider and connect this and store inside your S3 bucket. And the cool thing about this, it also understands the structure because my schema is applied to this, so it will generate a table inside the table flow that will have the same structure. And the way how we explore this, you already know this tool, Popsicle. It is super cool, and what it allows me to do is allows me to connect to this Iceberg table. Now, Iceberg doesn't define a engine to write the query. There's like RPC calls that you can perform. Usually, no one queries directly. You're using some sort of tool that knows how to query Iceberg. There's two options that I have here in this particular demo. One, it still uses Trino. In my table flow demo, let me show you. It has this configuration too. Let me show you this one. Yeah, that's better. It comes from Trino. Trino supports connecting to Iceberg, but in this case, I need to specify Confluent catalog and the Confluent key and in secret. And this is where I'm showing the region where this data will be stored. And because in Iceberg, you also have metadata and storage decoupled. You need to know where the data is actually stored and how this will work. So in this particular case, with my Popsicle, I do have a connection to my flights data. Where is it? That's my flights. And it connected to Trino. And if I'll query this, it will give me some sort of information about the canceled flight for the last, for the last 1 hour. Say some of because I just started generating my data generator in a few seconds. Let me run this again. You will see more canceled flights, so meaning that data will be getting updated. No more canceled flight. Trust me, it's there. Now, another thing is that what this will give you very good. Anyone familiar with this medallion architecture that was popularized by Databricks? So essentially, with the medallion architecture, we have 3 tiers of data. You have a bronze, silver, and gold. Usually, when the data arrives in some sort of place where it can be, some sort of like a raw format-ish, not maybe entirely raw, but maybe requires some additional massaging. It's called bronze tier. This is where you need to start preparing your data for passing to another tier. The golden tier is tier that you will be serving your API or you're serving your reports from. And the silver is something intermediate. It would be good enough, pretty good quality, established schema, so multiple other systems will inherit this and perform their own some sort of like golden tiers. So in this particular case, for my table flow, I do have this enriched flights information, and this is something that I can always do. Where's my enriched flights? I can always do from here. I can always do this on my client side. So I'm using Trino. I'm running this instead of my. I'm getting the very nicely looking table information about my flights. Say I'm putting loading. Say I'm extending this information by adding status here, pre-compute status, because I'm getting this information between departure and the scheduled departure and actual departure, getting this information. So this is where I'm already kind of ready to give it to next tier, to silver tier. But also I can run the same query inside my my Flink job. So this is where the Flink can be used in this particular use case as implementation of this kind of like a database, because Flink in this case will perform. Where is it? Give me back. Flink. Going here. Open SQL workspace. Yeah. And I'm using SQL here to do this enriched flights. I'm sorry, what? Did I say something? So what I'm doing here, I am using this same enrich flights. I'm inserting this enrich flights into my topic that I can go and materialize now. In this particular case, I'm using Superset, which is the open source tool that you can use to write your visualization. It has a Trino driver, connects to my table flow. So now my enrich flights were pre-processed inside the Flink and used the table flow as a storage. So now it actually makes this somehow a streaming database, except maybe the indexes are not supported yet, but stay tuned for some updates here. And I'll say create data set from this chart. Can we? Yeah. And let's do this one. Create table. Create new chart. Dimensions. Let's do simple word counts. Let's do delay in minutes, average delay in minutes, and we will have airline. So save, create. So in this case, I can plug this in my visualization tool and quickly build this dashboard. This dashboard will be updating because the data in the table flow will be constantly updated from the Kafka side of things. So that's kind of like a combination of other things. If you want to try, we have a sponsor from we have a word from our sponsor. If you want to try this, use this code, and it gives you, I guess, like 300 credits, so you can play around in Confluent Cloud. I'll give you a moment to take a picture of this. Thank you. Anyhow, now you feel probably even more confused after this presentation. It's like, what the hell? What was just that? And it's okay. It's fine. That was the whole point, because there's no right solution. I learned this by becoming an adult, and now I'm doing my own taxes. It's boring, but oh well. Only trade-offs. Now, let me give you also like a few inspirational points about when you're choosing a solution or what you need to take apart from the technical capabilities. Sometimes things that you already use or things that you already learn are good enough. If your organization already runs a bunch of connectors and you need to quickly and dirty build the dashboards out of this, just ask them if you can use this the connectors to feed the data into your database. And that's okay. That's fine. Use the tools that serve the purpose. You know, unless you get paid like me to do experiments, you come up with some crazy architectures. In most of the time, people are building these pipelines and building these systems in order to serve like a business tasks. And you know, sometimes time to market is more important than learning new cool tool that's written in Rust. Now, some people like to pay attention to performance. Of course, speed is important. Speed is important, how fast you're getting data, or like you really don't want to introduce new tool that will be making things slower for you or things like that. Like performance aspect is near and dear to certain part of the world. Like I came from Eastern European country. They love talking about performance. Why do you have scores? What's up? Scores. You can spend like a lot of time. There would be some dead code there, and that might be causing like you have a sleep 500. That removing the sleep 500 will increase the performance of your application. So you can spend a lot of time to optimizing your benchmark. But again, like what you're trying to achieve here, you get the maximum performance. Also, that's my favorite slide. Community. That's me. It's me telling you what to use. I'm just kidding. The way how I learned my first programming language was not, it was cool or not cool. It was the person who lived next door and I can ask questions. Same thing with technology. If you have the community, you have a group of people where you can ask the question and learn something, it's much more important than, say, I don't know, using monads and category theory, Scala, having PhD, if you need to ask the question, Kafka community was very open for many people who were asking questions. That's why Kafka became very popular. A lot of things that we do in Confluent in the community, trying to create the safe space where people can ask the questions, learn things. And the place where you learn things is developer.confluent.io. This is the place where you can have like free courses, all sorts of interesting materials. Community is also important. Like many times, so that's the reason why I say Iceberg is becoming like very popular, because even key vendors, they're actually charging money for using their tools. They're actually investing in this community. I just came back from the Iceberg Summit where Databricks, Snowflake, Microsoft, AWS, they were like sitting on the same stage and they were talking about future of this awesome open source project where, you know, the people outside of this stage, they were given the courses, they're given the workshops about the Iceberg. So community is important. I cannot stress this enough, and that's the reason why I have this job, is that kind of create the space where people can learn new cool tools. And I just here to entertain you, get you excited about those things. But actual work starts tomorrow when you need to go and start to figure out, okay, so how it will work in my environment, like what it takes for me to introduce these tools in my Kafka environment. And yeah, that's kind of like a very inspiring slide at the very end. So you do have some different application code. You have Kafka, and in between, it's just like a sea of monsters, area of exploration. Yeah, so there would be some cool things. And actually, this is a very good thing because it allows you to not only stick with one particular tool, but also maybe use different tool that solves different problems differently. With this, my name is Viktor Gamov, and as always, have a nice day.